Hello, everyone. I would like to welcome both our in-person audience and virtual audience to track 4, Translating Data into Actionable Insights. I am Lakshmi Randall from Informatica, track producer and moderator for this session. Our session this hour is how to make data science real to drive valuable insights. Managing and monitoring data science, machine learning solutions and models can be very complex due to various reasons like data veracity or lack of standards and so on. Especially as the ground truth changes, it's extremely important to update these models, manage these models, and monitor these models. So this session will provide insights on considerations, approaches, best practices, and lessons learned in deploying a robust AI machine learning solution. Our speaker for this session is Pramod Singh from Yodlee. Welcome, Pramod. Yep, the floor is yours. Take it away.
Yeah, thanks, Lakshmi. Right. So again, I know this session is on the last day and between lunch. I'm between lunch and you guys. We'll keep it more fun. I run the data sciences and analytics for a company called Envestnet Yodlee. We are a fintech company providing a lot of financial insights, to the banking partners and a lot of stuff, in the with the wealth domain, right? I have a team, of data scientists, business analysts, as well as, analytical engineers, right? Putting it all together is what, helps us derive value out of this data, right? So before I get into the detailed parts of the session, the kind of things I would like to cover today is, and I'll talk about something that we are all very familiar with called the transaction data. I assume all of us over here have a debit card or a credit card or track your financial transactions, online, right? So we'll talk in some level of detail about the systematic solution design of how do you go design a solution, which has a data science embedded into it, right? We'll talk about what are the key considerations trying to go make that happen. Along with that, I think we'll talk about, how the solution was developed, and we'll end that with, some of our learnings on the ground and, what are the key takeaways, right? So before I get into the business challenge, I wanted to take some time to talk about who we are as a company, right? So we are a financial data intelligence platform, right, which is transforming how the innovation and the insights are generated with the financial data. Our company works with 15 of the top 20 banks in US. We have 10 of the top 10, wealth management companies working with us. We have more than 20 million active users across US for which the transaction data flows through our system. And that transaction data is enriched using our AI and machine learning. And I'll talk in detail about, how that enrichment is helping provide us the business value, right? So that AI and machine learning is helping us fuel different classes of innovation, and we have the best financial transaction data platform that is on earth here, right? And if you look at the figure on the right side and the kind of things that we do, data analytics is the one which is the core component, which is helping first with the financial wellness, right? So it's helping users plan their financial life better, to move up the food chain in terms of their financial life, to help do the budgeting part of it, understand their transaction, understand their spends and expenses, right? Also in use cases like credit, we help with, figuring out what's the right credit to get at what point of time, at what kind of terms. And in the wealth management space, help plan your financial wellness, help plan your retirement and estate planning and things like that. So this is, again, a big overview of, what we do. But the thing to keep in mind is the base elemental data, which is enabling all of that, is a transaction data. When you go to a Starbucks and swipe your credit card, the transaction that's generated is a base element that fuels all of that, right? Or you went and transferred, some money to your one account to another one, or transferred money from your account to your kid's account, or you made a bill payment. All of those digital footprints are the ones which are enabling all these solutions that I'm talking about, and multi-million, billion-dollar industries are sitting on top of that. So before I get into the problem statement, then I think we have to keep in mind that a deeper understanding of the transaction data is the basis of everything that we'll talk about, in this talk, and why that is such a big problem as well as an opportunity. That if you're able to go solve that problem correctly, there's a lot of solutions that can be enabled here, right? So before I get into a lower level details, let me just give you an example, right? I'm talking about all financial transaction, whether it's a debit card or a credit card, or you're doing a banking transaction. But a simple use case of a credit card transaction, right? So all of us, are used to, swapping our credit cards. Within 2 seconds, you get your receipt back and the transaction is done. But even to generate that, right? A credit card transaction, there are multiple players who are playing in this space. I mean, the first one is the merchant, and there are 13 million plus merchants, that you will see in this space, in US itself, right? The merchant is where we are doing your transaction. This could be, your mom and pop store or a Walmart, or even, doing a transaction online, right? Then we have what we call gateways, right? Gateways is software and API which is picking up data from the merchant terminal or your checkout page on a website, right? And it's transferring data. So you have merchants, you have gateways, you have what we call acquiring banks. These are the banks who work with the merchants to onboard these merchants onto this whole financial topology, right? Then there are what we call acquirer processors, right? Acquirer processors play a technical role transmitting data back and forth between the gateways and the card networks. And I think we are all familiar with the 4 big card networks we have, right? These card networks provide, basically the technical infrastructure around the whole ecospace here, right? And defines the rules and the regulations around this whole industry, right? Then we have what we call issuing banks. And this is the name of the bank which is on your credit card, right? They are the ones who are working with the consumers. Depending on your credit history and all, you get your credit card. And issuer processors are the one who are working with working with the issuing bank, making sure the lines of credits are right and providing a lot of services for them. And look at them. I mean, there are hundreds of the millions of merchants. There are thousands of banks. And the combination is just enormous, right? But the point I'm trying to make here is that every one of these entities over here you see can influence how a transaction is recorded. And this is important, right? I mean, something which happens in like a couple of seconds. There's so many big players, so many different companies which are involved, and each one of them, independently of each other, even more importantly, can influence how your transaction is recorded, how the transaction description is recorded, right? And that's why I think it becomes important, that there's no real standards around in this space, and I'll give you some examples here, right? So I think keeping in mind that even a simple credit card transaction, have multiple players behind them, and each one of these entities can influence how a transaction description is recorded, right? So what happens as a result of that? You see on the left side, several transaction descriptions. You may want to intuitively look at it. I mean, looks like you're able to probably figure out that it happened in Kansas City. Not much there. The second one may be a Walmart transaction. But what you see is a very ambiguous transaction descriptions, right? This is the outcome. All of us have seen that on our credit card, debit card statements. You see a cryptic description like that. That's what flows in. So what happens, right? A transaction description by itself is very hard to read, right? It has random numbers thrown in, random letters thrown in, and as I said, in the previous slide, each one of the entities that I had shown on the slide can potentially influence how that description is recorded, right? Now, what also happens a lot of times, including me, that even your own transactions, sometimes you don't recognize those, right? And I don't know how many of you have called your credit card company figuring out what was a transaction, then you figure out, oh, this was a coffee I bought, during a trip, right? So that leads to customer dissatisfaction, and a lot of service calls, right? So that's another problem that we have. More importantly, the transaction description by itself stored in a data warehouse or in an online system is very hard to use for financial institutions, right? If you have the data which is looking like the data on the left side, it's very difficult to extract information out of it, build solutions on top of that, and generate insights from it. So that's the other part of the problem. So basically, the statement I'm making is that transaction data or transaction description by itself has very limited value, right? So if the problem statement is, I think, clear now, what would an end user need? Ideally, if I'm as an end user, right, an end consumer of this data, you would want a clearly defined merchant, right? So if you look at the transaction description on the screen there, I mean, rather than looking at that big string of numbers and letters, with some cryptic message there, you would want to know, okay, this was, in this example, a transaction at a Costco, gas station in Fremont, California, right? And it was a category of, automotive, not the retail part of, right? And you would want that to be updated real time onto your screen, right? So if you go from that description that I talked about to what an end consumer would like to get, right? So if you look at an input of this transaction description, right? So I'm trying to just set up the problem statement. I mean, this is an exact example of one of the descriptions that we get. We get more than 80 million of those every day, right? That description by itself very difficult to get value out of it, right? What is the outcome we would like to draw, right? And this is a real outcome from that particular description, right? So if you look at the description, an interesting thing about that is the merchant is the Dunkin' Donuts, which there was a signal for that. But more importantly, there is another merchant there, which is the intermediary Square. So, right, in fact, this transaction has two different merchants, right? The end merchant where the purchase happened, but also it has an intermediary there, Square. So the Square was used to go make a purchase there. The category of this transaction description is restaurants. Then we also have a granular category, right? Which in this case happens to be a cafe, right? Or I mean, it could have been a different class of a restaurant. The geolocation is West Valley City, Utah, and their website is there. The date the transaction happened is a swipe date, and you have a logo, right? So just contrast, what you have on the top as an input, which typically most of the financial institutions will have. And I'm only giving you some of the output fields here. In fact, we generate up to 30 to 40 different output fields here. But now that if you have the output there, I mean, you are limited by your imaginations on the classes of problems that you can solve in this space, right? So what I claim, so if you go from that cryptic transaction description to the entities that you can extract out of it, if you can do it correctly and do it the right way, there are some of the use cases that I have listed, right? There's a clarity in the transaction description, right? So if I'm an end customer of a bank, and when I'm looking at my transaction, I'm clearly knowing what merchant it was. I clearly know what category of transaction that was. If I clearly know, what geolocation that was, that gives me the customer the satisfaction, and I'm not confused what the transaction was. More importantly, now if you have that data in the structured form, that drives to the multiple financial applications like budgeting and your cash flow, cash management part of it. Now the financial institution can build solutions on top of that, right? And those are enabled really, really well, right? More importantly, on top of that, you can build out what we call the customer level attributes. And this is a very massive exercise that based on your transactions that you are doing, you can figure out what you are doing, what life stage you are in. You can profile them, whether you are a sports enthusiast, depending on the purchases you are doing. I mean, it's basically, I think, we can derive up to 3,000 different consumer level attributes based on what you are doing, right? This is also becoming very important if you look at in the credit bureaus. I think the way our scores are calculated historically for the last 100 years based on the payments you are doing. Now you can use real transaction data enrichments and figured out your creditworthiness in real time based on what you really are doing right now, right? I talked about credit underwriting, income and expense, I mean, a very, very important use case. Also, I'm sure all of us here in the room and the folks watching have interacted with the chatbots. I mean, you go to a bank site and you can ask, hey, tell me my balance. There are some of the banks which have incorporated that. Those are all fed by this enriched data. I mean, the chatbot cannot interact with the description I showed earlier, right? So it's enabling a lot of efficiencies, on the side of the financial institutions. It also done right, helps fuel data for market research, right? Now if you have all these transactions, you can look at, what's happening with the retailer like Walmart or a mom and pop store. You can do market research. You can figure out, you can do studies around if the recession coming in. So it enables multiple classes of use cases there, right? And as I said, once you're able to build lot of consumer level attributes, that enables, your marketing, your remarketing, your customer segmentation, right? And all of that is possible if you look at this elemental data, the very, very lowest level data, the transaction coming in, and if you're able to go put, the right AI behind it, you can do that. And obviously, I claim, I mean, there are hundreds of use cases that even I haven't thought about, right? Or we haven't thought about, as the right innovators come in, they will discover them, and newer cases will come in, right? But everything that we do sort of builds on top of that, right? So I claim that, that what is search for Google is enrichment is for our company, Yodlee, right? Because this is the lowest level enrichment that you can do, and you can kind of build things on top of that. So this morning, I don't know how many of you attended Thomas Davenport's talk at 8:30. He talked about what AI can do for data. And this is exactly, I think, what we are doing over here, right? We are using AI to look at something, as simple or complex you want to call it, like transaction description. And if you do it the right way, that can stand up multiple lines of businesses with their own revenue streams, right? A lot of times, this data is residing into a lot of financial institutions' data warehouses with very little value added, right? So I think transaction data enrichment, which I'll start to call TDE in the upcoming slide, I'll want to kind of set up the problem a little bit and talk a little bit about that, right? So let's take a step back, try to decode what the problem looks like, right? So the first part of the problem statement is that has very high variety. And all of you hopefully can relate to that. Look at this transaction description, right? I mean, these are all real transaction descriptions. I'm randomly picked up, as I said. This is a Walmart. This is a Walmart transaction. I think seems like it. Look at another one of these. This one also seems like some sort of a super center transaction. The description is getting a little complex. The next one doesn't seem to have a vendor or a merchant. Looks like an intermediary there. Look at something like that. Any guesses what that would be? I mean, any guesses? Parking, yes. Yeah. So some sort of a parking garage, maybe in Georgia, and looks like PayPal was used to go pay for it, right? But again, I mean, even intelligent human has to spend time to think about it, and even then we could only abstract out 2 or 3 different attributes there, right? It gets, this is probably a Hulu transaction. This one gets a little bit more complex, but looks like some sort of a grocery store there, right? This one is harder, but it looks like some sort of a message is passed into the transaction description. And remember, when I set up the problem statement, all these entities we talked about can influence that, right? Now this one again looks like a message getting passed there. This is almost no signal there. And the next one, last one, actually there's no merchant signal there, but it's actually a 7-Eleven store, right? Based on the geolocation. So what I'm claiming here is there's a wide variety of descriptions there, right? And I'll set that up in the problem statement. Second part is that the vocabulary explodes exponentially, right? Very rapidly, right? So for all of us here in natural English, I think what I read is that we add about 1,100 words every quarter or so, right? So if you look at the base words in natural English language, about 300,000 words there, right? I mean, if you look at the base words, right? In our space here. I'll give you some examples, right? So there's a quote unquote a word, say error mark, right? I mean, descriptions can change every day coming from the sources. I mean, you can have error mark, and these are all real examples, and JPMC, put together, or it can have error mark at JPMC or something, and you can see that versions thereof, right? And these are quote unquote legitimate words in a transaction description that you will see, right? And we're just trying to contrast this with how the natural English language progresses, right? Look at some example. We are in Boston here. I mean, we'll see the word Boston or Boston and make combined together, or looks like it's a Prudential building, but this is again, abbreviated a little bit there, and then you see the variance there, right? So these newer words keep coming in very frequently as part of the vocabulary of this transaction description, right? You can look at the word Victoria, which could be a merchant, but Victor IA is a legitimate city-state combination, right? It's a city in Iowa, right, for example, right? So how quickly the model can get confused there, right? Or a branch call versus a branch CA, these are all legitimate variations that we see in the description, right? So now compare with the natural English language, which has 300,000 words. In our case, it's 18 million, and that, which is about 60 times of the natural language, English language, but 18 million only in 1 month's worth of data. So you can imagine, the complexity of the problem. There are a lot of solutions in the NLP space which work with the natural English language. So you saw the variety. Now you're looking at the volumes of the data and the distinct words that we see, right? And the third part of the complexity is, which is even very interesting, is that they don't follow, these so-called words do not follow any patterns and can change any time. As I said, these are multiple players who are helping contribute to this description, and each one of them is not talking to anybody else, right? So, we have seen examples like that examples like hotels.com, that abruptly got changed to, which was followed by an address, abruptly got changed to ZZZ followed by an address, right? Or Dunkin' Donuts got changed to DD/BR, right? And these are all legitimate classes of transactions that descriptions that you will see, right? There is always, in terms of the complexity, we see a lot of temporal shifts happening in the data, right? We see abrupt temporal shifts happening, right? You have the merchant in the front, the merchant goes in the back, and these are very common that we see, right? And more importantly, no particular pattern in the name variation, right? We'll see a name variation, ABC, PIZ, and wines, and it could be ABC Pizza Wine Store, right? Or look at the next one, right? In that description, there's only one letter changed, but these are two legitimate different vendors, right? Tiny Thai restaurant versus Tony Thai. These are two legitimate vendors, but it's in a natural English sense, only one letter that has changed, right? And it does not follow an English. I can say this is my right hand, right? But I cannot say that my is right this hand. That's not a natural thing. Or Mr. Pramod Singh versus Mr. SP, right? But again, in this vocabulary, these are things that we see all the time, right? So if I look at the problem statement, then it's a variety, the volume, and there's almost no order here, right? So how do we solve the problem, right? That's what I think I wanted to set this up. So if I give it to a smart humans to go solve the problem, and again, I'll talk about, as we talked about in the earlier conversations also, a bit of a human in the loop part of it. So if you have given this to a smart human to go solve this problem, one of the first things we'll do is we'll look at anatomy-driven holistic tagging, right? So first thing we want to do is completely holistically want to understand the structure of the transaction, right? If you are only interested in one or two attributes, right, you can probably build a binary classifier to go do that, right? Or you can go build some rule-based engine, right, to do that. And we talked about in Davenport's talk that how quickly these rules become brittle, once you are looking at scale, right? So in this example, if you look at it, we worked with our team of experts. These are human experts, and we have created a framework, of holistic tagging, right? That every part of the transaction description will go classify that into one of those tags, right? So in this example, the 99 cents only is a vendor name. There's a store ID which is captured in this example. There's a transaction date captured. The payment type is captured. Sometimes you have data which is completely unidentified because of, it's masked out for certain reason. It talks about the purchase type, the transaction number, the date, and the state and the city, right? So now, I mean, the motivation is you're trying to now put a structure to a description, right? So first thing you do is a tagging. Second part is, and again, a human in the loop, is that you have domain expertise to identify the islands of special importance, right? And this is very important. Look at these two descriptions, right? They look almost identical, except for the two letters at the end, right? FE. But these two are very different transactions. The first one is actually a service charge. Second one happens to be a fuel purchase, right? So these are very different categories of transactions, right? But the human expert was able to identify that those two letters means a service charge, right? And this is where I think I'll motivate that how do we build the ground truth to go to help solve this problem, right? Second, look at the second example, right? So H&R Block, Walmart. I think the first intuition would be that the merchant is Walmart. But in this example, Walmart is not the merchant. It's a location for an H&R Block, right? Another example here, right? If you just look through this transaction description, looks like the Netflix or the WWE network is a merchant. But in this example, they happen to be the reason for the transaction, right? So somebody transferred money to somebody paying part of that, right? So again, the context becomes very, very important. And this is where the human experts, when we talk about the human in the loop, very, very important, right? A lot of the AI is actually, powered by the humans behind it, right? So if a human is solving, they'll be looking at that. But this is again now start to get into the next level of it. Now, if you look at our data classically follows the so-called 80-20 rule, right? What does that mean? That the 20% of the unique elements represents 80% of the volume, right? So when we are looking at all this transaction data, right, I think we do want to completely understand the complete structure of the data, want to look at all elemental variations that we have. There are parts of the transactions description which has more value trying to figure out what intent the transaction was for. And the third part, very important, is the human involvement, right? The human involvement in any kind of a bigger solution like that, will, bring in extra cost, extra times, right? So we want to very, very efficiently, use our human experts to go do that, right? So these three considerations are very, very important, right? Now, if I look at our distribution of our curve, right, a big part, and if I look at all the so-called words, right, and plot them out, each word, as I said, is a set of characters or numbers, demarcated by a space. If I look at that and plot it out, the curve looks something like that, right? They are, in that example, I talked about 1.8 million words, but a big chunk of them occur only one or two times, right? So we have the classical very, very, very long tail, right? So now if you're trying to put an AI framework on it, if you look at the left side of the curve, you want to dramatically sample from there. You want to go build up a framework to sample from there, but you also have to sample from the long tail. Problem with that is those when you do that, those are not very generalizable, right? Because those occurrences happen very very rarely, right? So is there a better choice? Any thoughts? You think we can do something better here? Or I'll motivate that by simple English language, right? If I say my name is Pramod Singh, and there's several folks of us, you all can say my name is followed by your name, right? But if I look at that and I codify that as one observation that my name is followed by a proper noun. So what I have been able to do that, take these n descriptions and codified that into one description, right? So my name is followed by a proper noun, right? So we got motivated from that, try to use that in our space and use a similar concept. So instead of trying to go look at the element level, can we go look at a pattern level? And then how do we define those patterns, right? Those are, I talked about earlier, how do we tag our data? These are different tags. And if you look at those tags and classify that, now you are able to reduce those 3 million descriptions to only 125 patterns, right? Now you can use your human experts to tag them. These are all very generalizable. A lot of the things in the long tail are taken care of, and then you cover a much bigger part of the population, right? So this is how that smart sampling framework that we have put together helps models to be very generalizable, even though you have an extreme long tail, right? So this is a part of the human intervention that we have, right? Now if I now take that motivation, start to transform, and how do we start to, what the learnings we have, how do we start to put machine learning on top of that, right? So it's very important that when you're trying to go solve problems using machine learning, you ask certain questions, right? And it's very important that we go look at all this data. As I said, we have petabytes of this data, billions of these transactions. In fact, more than 100 billion over the last several years. We have 80 million coming every day. First question you ask it, well, what all information is present there, right? Very important, right? Because we are not trying to solve problem for one element at a time. We are looking at the holistic solution here, right? So as I talked earlier, you can look at different elements that are present. You have merchant, you have geolocation, you have state, you have category of the transaction, you have a transaction types, right? What that also does, it keeps data scientists honest that you may have a newer class coming in. So this is not a closed set problem, right? And I'll give you examples how we saw newer classes of data coming in, right? So very important when you're looking for a generalizable long-term solution that you are looking at that holistically, right? Other part is you want to learn what kind of information can coexist or is mutually exclusive. Because that will help define what kind of right models do we do, because for each one of these entities I talk about, we have different models to do that. So for example, if you have an online transaction, you will not have the merchant city and state populated, right? Or the other way around, right? So, right? Or if you are doing a transfer between your two accounts, there won't be any merchant in there, right? So there are classes of transactions you can learn some elements which are mutually exclusive. Or if you have if the transaction type is a physical store, you would expect to populate or have the city and the state, right? And what our patterns are, quote unquote, grammatically correct, right? And you think through the temporal sequence of these patterns. This learning is very important, and I call this the initial part of doing the data science. If you do a due diligence here, that that really defines what kind of modeling approaches you should be taking, right? So I think with that, I believe the big part of the guiding principle of the enrichment solutions will be there, right? So now, not getting into the lower level details, now we have set up the problem to apply the machine learning part of it, right? So one of the first things we do is what we call data normalization, right? And again, not getting into the lower level details, in this example, for this particular problem, what you are doing is you are removing everything except the letters and the numbers. You are converting all uppercases, everything into a lowercase, and basically your each quote unquote element becomes your word becomes something which is separated by a space, right? So you kind of doing the data normalization. Then you are putting structure on top of that, which enables the structural learning to learn from that data and do your predictions, right? More importantly, after that is we have to learn what we call the elemental variations, right? So I mean, the examples I can give you, something like that you go bought something at Walmart, right? In that transaction description, at sometimes you will have that populated as WAL-MART. Sometimes you'll have WAL-MART -MART or WM or WMT, and combination. There are hundreds of combinations of like that, right? So you have to understand, and this is where I think we spend a lot of time understanding what we call the variations. They're all variations of a same merchant called Walmart, right? And imagine, right? There are, I mean, we saw that in the earlier slide. There are, more than 13 million merchants in US, right? And then you multiply that by the variation per merchant, right? I mean, even if you have just 10 variations per merchant, right? You're talking about a very big number of variations that you'll play in, right? So all this is happening, right? So we have this vendor name, and in real world, the merchants open, they shut down, newer one comes in, two of them merge, they change their name. This is all real life, right? Happens all the time, the world we live in, right? So what we do is we do a very systematic integration with a third-party vendor who monitors the market. We pay for that, the systematic integration. We update that data very frequently on a weekly basis. So the merchants that we are calling out are calling out from the merchant, the exact name that this external database has, the reference database has, right? So that the variations are captured in the background, but we are seeing a clean merchant name, right? So you would not see like 300 different variations of Walmart. You will see Walmart Inc. as the merchant, right? So again, this is a systematic integration with a third party vendor to go do that, right? And the last time is, as I said, these are multiple models getting built. There are some predictions, which are completely dependent on other element, right? So I'll give an example, right? So if you found the vendor, the merchant was Pizza Hut, right? The category is restaurants, pizza, right? Or you found the other one is Olive Garden. You figure out it's restaurants, and Italian, right? Or it is Best Buy, right? So that happens to be the store, right? So in this example, if you're able to find the merchant, category follows that, right? So category is completely dependent on what the merchant is, right? So this is what I call the entity-specific prediction in this example. Now the other way around, if we are the model for category, so if you are finding the salary if you are predicting the salary category, right? I mean, all these vendors I talked about, Olive Gardens or or Pizza Hut or Best Buy, they all pay salaries, right? So in this case, the salary is not dependent on who the merchant was, right? So you see, you can go both ways, and you have to be very smart figuring it out. In some cases, these are completely dependent on one of the elementals. In other cases, it won't be, right? So I think hopefully this sets up the framework of how the enrichment is done, not getting into the lower level details. What we have learned over the time period, right, that the pre-trained off-the-shelf models are less effective. Our data has very specialized context, as I talked about that. It has a very specialized vocabulary, and we have built a lot of proprietary algorithms based on state-of-art techniques. Classically, we use a lot of these things. As you can imagine, right? I think we use RNN and BiLSTMs, to do that. A lot of active learning happens, transfer learning happens. But what is important, though, is that we are not using the models as is, right? There's a lot of, I think, the transformations that we have to do, how to ingest your data, a lot of other extensions that we have built, and we have put a lot of our proprietary enhancement on it, and that has been captured as an IP. So we have several patents, in this space to go do that, right? So this is, I think, the way I think we can think about, solving the problems. I've taken a problem, talked about, how do we solve that, but next part of is how do we take that solution and make it real, right? So I mean, we all know the real world machine learning systems are vast and complex, right? And effectiveness of any big machine learning system depends on the underlying data architecture, right? And the classical three things we talk about, the scalability, both in terms of load and performance, the reliability in terms of handling software, human errors, and even the hardware errors, and maintainability, right? These are three operating principles that you have to make sure that that you can work with, right? And I claim very strongly that in spite of all the complexity I talked about, developing a machine learning system and even deploying that is comparatively fast and cheap, and this is relatively speaking, right? But maintaining them over a time period is hard. And maintaining them at the high level of accuracy is very hard. So everything I've talked about so far is essentially around model, right? How do you get to that, right? But if you look at, how do you basically build a system to go deploy, these are all the components you need. In fact, this is a paper that Google published in 2017, I believe, right? Talks about the hidden technical debt, right? And we completely agree with that. We completely agree with that, right? I mean, all the complexity and all the pride we had about solving a hard problem is a very small part of the whole ecosystem here, right? Unless we have all these components, done right, you will not be extracting value out of that, right? So everything from data collection to feature extraction, data verifications, you have to build your serving infrastructure for spikes. We have days when you have hundreds of millions of transactions coming in, versus you have days when you have tens of millions coming in, right? So it's very important, and I think a lot of times, especially the folks in the data science side, look too much on the model side of it, not looking at everything else, right? But if you're looking for a real world deployment, you got to go look at the whole infrastructure and make sure that works. And we completely agree with, what was written by in that paper that Google published, right? So this evolved into what a series of steps that we internally follow and have very formalized that very rigorously in my company. Again, I'm not claiming this is the only way to do that. In this conference itself, you probably would have seen multiple ways to do that. There's nothing right or wrong about it. This is how we have evolved, right? Over the time period, right? So first part, what we believe, and the example I'm talking through the transaction data enrichment, is you have to translate the business problem into a data problem. That's the first thing that you got to do, right? And the first part I talked about is a synergy between the product teams and your analytics and the data science team, right? And this is where a lot of learning happens, in terms of, do you understand the business problem? Do you know where the data is? Does your data have any sorts of limitations, right? And as you kind of go through the food chain, this is where what I formalize in my company, I call it a discovery phase. And for all projects which have a data science component built into that, I have mandated that you have a discovery phase, which basically the outcome of that is a go, no-go kind of a decision, right? Where you go scrub data, you formulate a AI machine learning framework, you do data swimming, try to solve the problem at a small scale, iterate through that, right? To me, that's the most important part, right? I mean, there are examples where you could have saved millions of dollars not approaching a problem which was not solvable or not solvable in the economic sense that you wanted to go solve that, right? And that's an iterative process that you go through, primarily done by the data scientists and our engineers together, along with the business analytics team. Then you go through the journey of representing data, building models, doing a soft launch. But I do want to talk about, in real life, a big synergy between your UI and machine learning, right? A very classic example I'll give you, and I think all of us are familiar with nowadays, when you type things, and the machine learning model, in a lot of these editors now, right? If it sees if the machine learning model is predicting that your spelling is wrong, and it's very confident that spelling is wrong, and also very confident that it knows the right spelling, it will go fix it for you, right? So what is the model doing behind the scene, right? Behind the scene, the model made a prediction that spelling is wrong, and it has a very high confidence, it knows the right spelling, it populates it for you, right? So a lot of times what you have been able to do is, you have been able to take the UI to go give a better experience, right? And like all other models, when you deploy that, you get client feedback and you iterate through that, right? The process that we follow, very important thing, and I'll briefly touch on that, is while doing that, we are continuously monitoring our outputs. We're continuously monitoring our outputs for both, using what we call supervised learning and unsupervised learning. And I'll talk about that, why that is important in the world that we live in, right? So quickly, I think touching the sort of the deployment topology. So we have like 3 different use cases, right? So if you look on the right side, and that's an architecture of how TD is deployed through an API. We have a batch way of deploying it. We have a streaming pipeline way of deploying it. And then we have a real-time APIs way of deploying it. These are 3 very different use cases, 3 different lines of businesses, that we do that. So in the first one, the batch case, we use Spark processing, for efficiency, massive amount of data, the batch data that we go through that. I think Spark is the one which, helps us out there. Streaming is also a very important use case, right? In some of the applications we have built that we have monetized, streaming is a requirement, right? So you use microservices written in Kafka streams. You use gRPC to go deploy that for efficiency. And the last and the most common one is, the deployment through the classical real-time deployment through the APIs. You make an API call, you get the results back, right? And so this is a quick overview of what we call the deployment topology. What is an outcome? Doing all of that, over time period, we have evolved through our journeys. We have learned that we today process around 80 million transactions every day, right? And you have to have a sub-second response times, of these going through. A lot of these, as I said, are happening in real time. Keep in mind, in real time, you are processing this ensemble of 18, 90 deep learning models, right? and processing through that, optimizing all of that, and you have I think the timeout, if you're not able to get the response like in 50 milliseconds, it times out, right? So you have to do all that, in that time period. As I said earlier, we have more than 40 attributes that we can potentially derive from there. There are multiple probabilistic models done, and the team has now 5 patents which are granted and more coming in as part of that, right? So what are our key learnings, and enablers for success? The first part I'll talk about more from my developers, engineers, or data scientists point of view. The learnings that we have as we evolve through that, is standard code structure, right? This is more from a practitioner's point of view that, you have the right standard classes, you have right standard templates to go do that. And this, again, is a learning because we rewrote the whole system after deploying that, and this is what we realize that, when the teams grow, new people come in, it's an archaic class of code, so that you go standardize that, right? Second one, for efficiency, we go from, the REST APIs to to using the gRPC. This is definitely has helped us, with the efficiency. This is a thing that the team learned and has done very well with that. We also went from what we call the monolithic to a distributed architecture. This was, again, a huge learning for us, right? When we initially wrote that, we have all this as a big black box, monolithic black box with all those models embedded here. Now you look on the right side, now these are different modules, right? And these modules are doing one very specific things, right? So this has really is helping us now, because now it's easier to, if something goes wrong, it's easier to find. If you want to go react fast, you can go react very fast. So this is, I think, a learning that, over the time period that we have done, right? Another learning is you do not have to run model every single time. You learn, you cheat from the outcome of the data, right? So caching the outcome, right? The frequently occurring patterns, right? If New York, the word New York is followed by NY is a conclusive, city-state combination, you just read off the cache, you don't run the model, right? So that gives, when you're talking about, microsecond efficiency, this cache becomes a very big thing for us, right? So, there are, huge amount of cache. So it's very interesting that, as the model keeps learning, you invoke model less, you go read from the cache much faster, right? So that's the learning we had as we go through that. The other thing we learned is, especially these models in the real world we are in deteriorates over time if you do not look at it. And the two primary reasons in our case, right? One is the description changes. The description composition changes. Walmart can be called, WMRT. Boston space MA becomes Boston MA. So this is a very common thing, which, if your models are trained, these things change. That can deteriorate the model. Second one is actually a little bit more severe, right? The financial ecosystem is continuously evolving, right? So when we started this thing, there was no Uber Eats, right? The data started flowing in. Nobody calls us and say, hey, new category is coming in, Uber Eats, right? So we have to go learn from that, right? So Uber had Uber Eats coming in. Apple introduced Apple Pay as a payment methods, and then payment checks, new programs come in. The second one is actually more severe, right? That we have to go codify for that, right? So what do we use as a basic elementary framework to do our model monitoring, right? So in several of the models that we have, we use an ARIMA-driven time series algorithm. We train a competing model on the last 2 years worth of data. We go make some predictions, and we refresh the model every time. And every time we generate the prediction at 95, 99% confidence level. And anytime those are breached, then we bring in the human intervention. You go figure out what's going on, and go through that. The team is also now started to build what we call the AutoHeal framework to try to go do that. But this is very important in terms of doing a real life thing, and these models are trained, every 30 days, right? So the outcome of all of this is, right, having done this over the years, right, I cannot talk about this in terms of numbers, but I can say that very big part of the revenue of this company is directly dependent on the enrichments that we are doing, right? It has helped stand up a newer lines of business which are completely driven from the data science that we do here, right? It has really enabled do what we call the hyper-personalization. Now that you have those entities that you can go work with, and a big contribution to the revenue of the company, to the bottom and the top line of the company. On the other hand, in the interest of time, I think over the last couple of years, because you are able to extract out these entities, there are so many macroeconomic research that we have done, right? We have, especially during the COVID time period, we figured out I mean, one very small, I think, thing we found out that when the stimulus check came in, a very big percentage of that actually went, people use that money to go invest in stock market. I mean, that was not a very intuitive thing that you would have thought, right? But that's what happened. We started to see that kind of a thing, right? So just because, I mean, we were able to go extract the information out of, a very cryptic description which resides in a warehouse somewhere, nobody uses it, it stands up a newer lines of business for us, right? So key takeaway, right? I think I know we are getting to the time here, right? I think if you combine the data science, and I have always said that, it's the so-called man-machine congruence, right? If you combine your data science with the art of formulating the right problem, you recognize the value of ML, right? Value addition, you design a solution, and you maintain a consistent outcome. If you're able to do all of that, right, you do get real application of data sciences, right? It is not easy, right? As I said, building model is comparatively the easier part of the equation here, right? And you're able to solve your real life problems, you can maintain the solution, and can have competitive edge. And to end the talk, if you only want to take 3 things out of this talk, right? Number 1 would be you clearly articulate the business problem you want to solve. That's number 1 thing that we have learned, right? If only 3 things you can take out, the second is the availability of data, right? Understanding where the data is, making sure that you have the right data platform and the structures around is the number 2 things. And yet you can see that, through the talk that, why was that important, right? And the last one, and the very important one, is that you do not take shortcuts, right? Do not take shortcuts. As I talked about it, our problem, we could have solved that, using keywords that gives you an instant gratification, but it becomes very brittle after a long time, right? So foundational AI, focusing on the quality is very important. If nothing else you take out of this conversation, take out these 3 things, and then that will be very nice. So thank you very much for your time. I really appreciate that.
Any questions from the audience? So Pramod, how do you find balance between improving data versus improving models, right? So how do you make the decision? We can address this problem by just fixing the data rather than creating another version of the model. So talk about that.
Very good question, Lakshmi, right? And yeah, you're right. It's definitely a balance, right? And we see that all the time, right? I mean, as I evolved through my career, and I remember, I had worked at Walmart, I had worked at Hewlett Packard. At that time, the mantra was that you fix the data as source. I mean, that was the so-called single version of truth. I mean, that you go fix the data as a source, right? And in some sense, I think that that should be the mindset. But in real world, when I'm reacting to these transactions are happening in real time, and the source system happens to be 3 hops away, right? You cannot do that, right? So we have these things, what we call short-term fixes. We have created a system where we have an equivalent of a hot patch for data science models, right? We call it nfix internally, right? Which is equivalent of a hot patch for a software, right? That you are able to kind of correct the errors. Then we go back to the source system, tell them that this was wrong there, and we have a feedback. So that one is a little bit more cyclical thing, once a month kind of a thing, but we're able to solve the problem itself, right? But in a theoretical ideal world, you want your data to be totally clean, right? So you don't put and that's a balance that you have to do that in a real world, especially when you are doing this real-time kind of an enrichment, and this is the real-time impact that you have to do the balance. And we learned, right? I mean, there were time, and in fact, we had to build out a full framework to put a so-called soft layer on top of TDE to manage that, right? We internally call it nfix, as I said, which is taking these outputs which are wrong, you fix them through a sort of keyword-based system, and next model outcome, which happens every month, it becomes part of the model, right? And then they iterate through that. Yeah. Very good question.
Yeah, thank you. From a culture perspective, are these data scientists part of business teams? Are they part of IT teams? And what are your thoughts on where they should sit, actually?
Very good question. Right? I think there's no one-size-fit model. I have done this at much bigger companies. This is a completely smaller company. Depending on the maturity of the organization, like we talked about, I think yesterday we had a talk, right? And somebody said, in a bigger organizations which are digital first, the data scientists are spread across in different business units because this is part of doing the business, right? But if you're smaller companies, what I have realized is that you need a critical mass of them working together, right? Because from the career progression perspective, right? You have one data scientist embedded into one business unit. It becomes a problem in terms of the soft things around how do you progress a career, how do you measure that? They're not learning from each other. So I think it's a balance as you mature. I mean, in an ideal world, I would like them to be. I mean, data science should be like now should be, or in few years should be what doing querying is, right? Or the data warehousing is the way it was 20 years ago. I think this is where data science is right now. So I think in a companies, as you are evolving through the journey, it's better to have small, at least core teams and hub and spoke on a model. But as you evolve through that, you can have them embedded separately.
Thank you. I think you briefly talked about data tagging. So how critical is data labeling, and is this done manually, or there are automated solutions for data labeling?
Very, very good question, right? And I talked about that, and I have always said that your AI is as good as the human behind it, right? And I gave examples. So in our case, we actually have an in-house team of the labelers. These are the people who are experts in US retail, right? Example I gave you, right, where only 2-letter different. So these are the experts who told us that these two transactions are different, right? And we're getting smarter and smarter in that. Imagine a space of billions of transactions. We are tagging few 100,000, right? But you have to get smarter with that, right? So your models are as good as the ground truth behind that, right? So that's a learning that we had, right? If you compromise there, everything else, down the line will suffer, right? So that's where these and what happened is, in the beginning it was very manual. Now these teams are getting smarter. They have built their web crawlers. They have automated a lot of that process. So it's a very interesting synergy which is happening from both sides for us, right?
Thank you for the talk. A great talk. So you had one slide where you mentioned there's 3 million records, and ultimately you found 125 patterns through 125,000 patterns through POS tagging. So was that through clustering, or how did you come with 125,000 patterns on what comes after what?
Good question, right? So if you look at, we were able to put structures, right? So the example I gave, right? So all the variations were captured, right? If you start to look through the tags, right? We have these different 30 to 40 different tags, right? So we looked for the patterns in the tag, right? Not in the value, right? So if you have city and name followed each other, right? So rather than going through, in that example, millions of those, you found a pattern that the state is followed by city, right? So that became one pattern, right? So like that, I think you were able to go reduce those, right?
And those patterns were just for named entity, or was that for other things also?
Other things also. Everything in the description. So that's how we see. In the beginning, when you do that, and this is very important, I think if you are looking for a long-term sustainable solution, in the beginning we said, oh, the most important things are merchant and category, let's just go build a classifier for them, right? But what we realize, if you are trying to build a sustainable solution, it's much better to completely understand the topology of your transaction. And that has really helped. There's so many solutions which have come, like store ID seems like a sort of a side thing, but now that we can extract that is helping in multiple use cases, newer classes of businesses for us, right? So rather than just, because if you go do that, you are basically now creating your ground truth for that, only that one element, right? With the holistic tagging kind of and redefine the framework for us, right? So that was very nice. Thank you.
Thank you. I thought that was fantastic. So I wanted to ask about, do you ever tag as these transactions are coming in, are any of them tagged as needs to be manually reviewed? Is there anything that's not picked up by, and then maybe it gets built into the model after you understand the logic, but are you at a point where everything's automated, or is there still any kind of flagging for a manual review?
Oh, very good question, right? No, in spite of all the science we have, and no AI model is at 100%, right? So a lot of time, and I talked about how we build, and every model has a confidence level, right? If we have a confidence level which is low, there are two things we can do, right? And then remember, until we find the map matching in that external database, we will not populate that, right? So if our confidence level is low and we do not find a match in that thing, we will leave it blank. Right? So, so you look at the precision recall for the top merchants, and we are around 99%, right? So there are transactions that we would rather, in a sense, we would rather not give you a vendor than to give you a wrong vendor, right? And the equivalent of that is if you look at Google, right? How many times you go search, and the first link is the one you were looking for. I mean, it's not 100% of times, but Google has built a safety network. If first doesn't work, go click on the second one. Second doesn't work, go click on the third one, right? In our case, we do not have that luxury, right? If we called, you went to Walmart and we called it Walgreen, that's wrong, right? So you have to kind of build that safety net to go make that happen, right?
Great. I would like to thank the audience for joining us. Another round of applause for our speaker.